Good evening, guys. Welcome back. So today, as I have promised to you, that I will be talking about the story of real numbers. By the story of real numbers, what I mean is that how the real numbers came into existence and why limit is a very integral part of um, real analysis. Why limit is probably one of the most influential mathematical understanding to enhance the perception of numbers in terms of real numbers. So that's my purpose today, so that because this will never be taught. I was never taught these things in my undergrad days, like how the story came up, what's the crux of it. So usually in my college in ISI also, like I'm sure it will be there in your colleges also, that we are taught that a real number field, we get axiom of completeness and all these things. There is an unordered field or ordered field, something like this. Ordered field, yes. And then it's ordered filled, and then all these various properties come up, but how they are sewing together and what's the story behind it, so those written between the lines is never told explicitly to you, probably because the professors and the teachers assume that it's your it's your duty to learn from the books. In that way they are actually correct, you can learn it from books, but I think it's my duty to share that in simple language to you, so that you get that where and how the human beings are thinking. The reason I teach this and I share this knowledge to to my students is the following, that uh, they get to know, number one, the history of what's happening, how it has developed, how it was grown in the hands of human beings, and uh, also it guides you towards an understanding of how problems are being solved, how things are, new theories come up. So that will actually essentially um, impact in your problem solving skills in general in life, in whatever you're applying those. So that enhancements of thought processes will help you understand and perceive and live your life in a better way. So let's get started. um, my agenda today is of two three folds. Number one, I'll be telling the story of how numbers came up. Numbers came up or were discovered, most probably, like, and why limit is important. And the second part will be about understanding like rational numbers and irrational number in a much more rational numbers and irrational numbers. Also they're intertwined together. And finally, also I'll be talking about how, like, why the supremum and infimum concept, essentially it's a together, one piece together that creates a story. And limit, this also comes here. So essentially it's a together, one single piece that I gotta be teaching, but it has some subsections of lessons that you will probably take away at the end of the discussion. So let's starting with the story of numbers. As I've already, I already tell people that mm, numbers exist. If you watch the film called um, The Oxford Murderers, I think Murderers or Murderers, something like that. It's a really beautiful film. So there, essentially, I think it's one of the starting, scenes where a professor of logic is talking about numbers, and talking about the, like, he told the audience that what's the use of numbers if it cannot predict the hurricane, or it cannot predict when the cancer will happen, okay? If we cannot save human lives, so what's the point of numbers then? He also tells you that tells the corresponding people who were listening to them that, if two uh if 3, 5, 7 happens, then what is the next number in the sequence? The next number probably will, people say, 7, 9, right? But it can also be 11 if we are considering the odd prime numbers. So essentially it's telling that math or mathematical logic is, see, if we cannot predict something like with definite thing, of course we can predict in a statistical way, but essentially his point that he made, that the math or numbers only exist in the minds, which is a very deep philosophical point of view. Rather, there was a philosophical question called, it was his name was Ludwig Wittgenstein. uh, I forgot. I don't want to write. Okay, let me search Ludwig Wittgenstein. Just give me a minute. Wittgenstein, and he has a book called Tractatus the Philosophicus, something like that. I'm sorry for not, um, uh, right, telling you the right word. So the question was that, does truth exist? And essentially, or like, how to find the truth, or does truth exist, on this line of thought. And essentially what he has derived mathematically by logic and logical steps was that truth exists only in the mind. Okay, so you have to understand that everything that math has done is only for, it's just a play of the mind. Okay, math actually doesn't exist in nature. It's, we are using our mind and we are using a math as a tool to perceive the nature in a certain format. That's why we cannot uh, measure a thing more than math. Okay, so you have to understand the limitation of mathematics. So mathematics is exists in the mind. It's a tool of the mind to perceive the nature around us. Nature is much bigger than that. If this nature, this is math. Once upon a time, so this is our mind, or this is us, our mind. We're using math as a tool to perceive nature. Okay, there are other things that are undiscovered too without mathematics. Just like example, like, just for example, the eyes cannot perceive ultraviolet rays or other kind of rays. Okay, infrared rays. Similarly, math, there exists something other than math. Okay, other than mathematics. Everything you cannot explain using mathematics. And it was also discussed in Gödel's incompleteness theorem. So you can read all about these philosophical aspects of mathematics, and it's interesting. If you're a very ardent follower that mathematics explains everything, it's not. Yeah, it should not. Yes, so naturally there exists something more than math, and that's why your personal beliefs comes in. Anyways, coming back to what mind, why I told mind, because these numbers are, so there was an experiment done on birds and monkeys and all those animals, that, I mean, non-human animals, that how do they perceive numbers? Like, so essentially, a parrot was taken, and the parrot was given, a bowl, three, I'm just telling you an overview of the experiment that was done by the psychologists. That five were there. In one there was one chili, in another there was two chilies. Okay, and here was 3, 4, and 5. Dot dot dot. So what happened to the parrot was, the parrot, of course, first these two were shown. Okay, and parrot selected this one, and then 2 and 3 were shown. The parrot selected this one. Okay, and then 4 and 5 were shown. 3 and 4 were shown, shown to the parrot, and the parrot selected the 4. But when 4 and 5 were shown to the parrot could sometimes selected this, sometimes selected this. That means in the mind of the parrot, The number system, and Parrot doesn't have the consciousness, doesn't have the a huge prefrontal cortex to count the way human beings have done, but to it there is a measure of moreness. There is a measure of more, that two is greater than one in this kind of orderedness that real numbers have. So uh so the Parrot has this, like, it for them it's like, you can understand, for Parrot it was like 1 2 3 4 and infinity. Okay. Or rather 1 to infinity, 1 2 3 and infinity, because 4 and 5 everything was similar, right? So the Parrot has this perception of numbers. Similarly, the question comes that, then how did human beings started discovering numbers? That's a very natural question that you should always ask yourself, that how did human beings discover numbers? Like, did they suddenly start realizing? So this is where history comes into play. History tells you the story of everything. There are great history of mathematics books. I have been glad that I was interested. Like, I have been made interested in the history of mathematics by one of our professors at ISI. His name was Amartya Kumar Dotto, and he's like, and I was profoundly interested in history of mathematics because I somehow felt that history of mathematics gives a story element to your understanding, where you understand how great beings have thought about stuff, and just like you write to read stories, so history of mathematics gives you a story of mathematics, and that's worth living for, that's worth learning. Okay, except studies and all those exams, stories are always interesting. So that's why it's my duty to tell you these things, I believe. So how did human beings discover numbers? They didn't discover numbers like in one random day. So I give this example that they first saw two maple leaves. Okay, so how maple leaves looks like. Maple leaves look like this. Five. I'm sorry for the bad diagram. Like this, as far as I remember, maple leaves. Let me search it online. Yeah. I mean, not exactly like this, but there were some color, like this. I am very bad at drawing. And maple leaves, one best aspect of this maple leaves is that, I mean, I think what they believed is that maple leaves looks like the fingers, right? It looked like fingers. And essentially, human beings, connected these things, that why it looks the same. Like, there is some connection between it. And this connection, what they derived is that came out to be natural numbers. And this connection between them lead to the development of natural numbers. Like, they started counting 1 2 3 4 5. And also, why fingers come into play, why I always tell the story of fingers, because with the 5 plus 5, 10 fingers, and the 5 plus 5 fingers, people actually started counting in 10 in decimal places. That's why it's like 0 1 2 3 4 5 6 7 8 9, and then again 0 comes. So 10 digits came into place. That's why the decimal system came into place for natural numbers. Okay, so this is how natural numbers were discovered. So natural numbers was the first. It's very natural, like, because it's used for counting. Natural numbers, it's used for counting. Counting objects. Oh, okay, there are 5 goats. I'm going to trade these 2 cows with these 5 goats. Are you going to do it? Yes or no? So this is how the trading was happening, because because that was the only living thing. I mean, live, for transactions, the economic transactions was important. Okay, I have the 6 gold coins. Will you trade those 10 silver coins with me? Yes or no? So just like this, okay, so that they can count things, because counting gives a measure and it's important. Okay, so now I will go into a bit mathematical aspect. This was not exactly how, I mean, exactly how in a normal people's life mathematics evolved, but essentially it was evolved like this. And you will see how we have come for how much we have come forward, and you should be thankful for what you are, where you are right now. And then what happened that people started, mathematics people, like, this came naturally to them, is that, is there a number? So is there a number x such that which when added to any other number, let's say 5, gives back 5? Any number, it can be any number here. And that's where they discovered zero, the concept of zero. That it's defined, zero is defined as a number. It's introduced a new number such that which when added to any number gives the same number. Okay, that's very interesting. And then this gave rise to natural numbers union zero, which you can call as whole numbers too. Okay. And then people asked this simple question. By people, I mean mathematics people. Okay, mathematics, and it was naturally an extension of the real aspect. Okay, so then the concept of date came. Date comes. Okay, date. Date, DEBT. A date comes, that I am in date. Someone has borrowed me money. Okay, someone has borrowed me money. So is there any number x as that which is when added to, let's say, some other number y, then it gives back 0? That means I'm in date of y rupees, or you are in date of y rupees. So, and that's why the concept of integers came, because the solution of x is nothing but minus y. The solution of x is nothing but 0. And that's why the concept of integers came, negative numbers. Okay. Now, negative numbers and integers have some great properties. Like, so integers, understand. Let's talk about natural numbers, integers. And we have these operations we can do. Okay, these operations were known by people: subtraction, minus, multiplication, division. So if we add two natural numbers, then we get natural numbers, right? So this is true. If we add two natural numbers, then we get a natural number. That's true. If we add two integers, we get an integer, right? If we subtract two natural numbers, we don't get natural numbers, right? If we multiply two natural numbers, we get a natural number, but this is not true. Great. Now for z. For z, if we add two integers, we get an integer. If we add two, subtract two integers, we get an integer. If we multiply two integers, we get an integer, but this is not true. So somehow down the line of history of mathematics, this idea of why, like, what kind of numbers made this, like, dividing like two kind of numbers give the same type of number comes, and that's why rational numbers and fractions came. So people ask this simple question, that is there a number x such that which when multiplied by y is an integer gives, you understand here, whatever the y you're giving here, y is a natural number. Okay, here whatever y you're giving, it's an integer, because you have updated the system of your arsenal of numbers. So is there a number x such that which when added to y, which when multiplied to y gives 1? So when you will learn, probably you've learned mathematics in your college, or probably so these are called identity elements. Okay, you will see mathematicians have this is multiplicative identity, this is additive identity, and these identity elements are very interesting, because that makes this is a story of that has been built over the past years. But these are real life problems that people have um question, because they ask that, okay, I want one cake of size, of this much gram, and I want to distribute among my three sons and two daughters. Okay, so how much should this each of those amounts weigh? So that's where the ideas came. Okay, this were natural problems because after the death of the parents, their children inherited the land, and they need to distribute over the, they have now, they measure the land and they need to distribute the land, right? So how do we do it? That's where they discovered the idea of fractions. Next time when you teach about numbers, or when you share about numbers to your juniors, to your sisters, to your brothers or cousins, or whoever you're teaching and sharing, please state those aspects. Okay, that will make them interesting. Yeah, you will play an important role in better education of the country. So, and that's where the whole idea of rational numbers came in. Q. So rational numbers are the set of all those a by b, such that a belongs to z and b belongs to natural numbers. So we did this last day. Unique definition, a by b. Also, you can divide by z and z non-zero z, where a and b are co-prime, but let's do it by this method. The interesting aspect is that the q, what you have seen, if you add two q's, it's q. If you add two rational numbers, it's rational. If you subtract, if you multiply, if you divide, all of them are rational numbers. If you multiply by non-zero, divide by non-zero. And that's why we'll see this is something interesting. This is called in mathematics, in modern mathematics, called ring. I think this is called a monoid. I'm not sure. Just have to check. If you're from a mathematics background, probably you will know this. And this is called a field. A field is a set of numbers which which when you add it, divide, and whatever you do, like whatever these operations you do, it always turns out to be inside that set. This is called closed property. And this is very interesting because you know this is how people have this, all these ideas are nothing but checking the closed property, closeness property, because this plus minus subtraction, plus minus division and multiplication are all real life objects, okay, that human beings saw and developed, and that came as a natural existence in mathematical, abstract mathematics. So they define like this. These are called binary operations in mathematical, binary operations. Yeah, but it has developed right now to more abstract operations. Binary operations are different, but the basic idea is this, that this is how the thing were developed.